up the slide deck. Hello everybody, welcome to CONDG, and it is 3 minutes till 6. We don't have enough time for another round of trivia, so I thought I'd throw the slides up there and give you a chance to not block the URL, but make sure to go follow us on Twitter, sign up on Meetup, put us in your web bookmarks, whatever it is you kids do these days, because we got some announcements and stuff coming up. Things are changing from month to month, so you want to keep up with those latest meeting notices online. I'm going to start us off with our intro slide deck here in a few more minutes to give people some time to get in and sign up for Twitch accounts if they haven't already. You're going to want that Twitch account to ask questions and to win prizes today, so give you some time to do that. You can certainly watch without signing into Twitch, and you can ask questions without signing into Twitch. But if you need time to do that, now is your chance. If you're wondering about my lighting here in the background, the lighting in my house right now is kind of messing up with my green screen, so it's a little bit off, but I think we'll survive. Seth is standing by, ready to go. A great presentation today. Can't wait to hear it from, I think, at least the second time. If not the third time. This is a presentation that has been at conferences and things over the years, and I've really enjoyed it. And of course, Seth and I used to work together, so but I'm not just saying that because we used to work together. It really is a good presentation. So we got Alan in the chat. Alan Barber, he is one of the organizers here at CONDG. Calvin A. Allen, also there in the chat. Hope you all enjoyed trivia. If you want to, if you enjoyed the trivia, please let me know in the chat there. Oh, I got the emote wall up. I need to take that off. Thank you for that, Calvin. I want to leave sort of the crazy stuff off. For the stream, like when people follow and subscribe and stuff, it usually throws a bunch of fanfare up, so I'm going to turn that off so it's not so distracting for a presentation. But yeah, if you want to submit your own trivia questions, you can do so. It'll be featured in a future stream. If you like the trivia, let me know. I just thought, I had it ready, so I thought I would give it a try for CONDG this time. See if you all enjoyed it. If not, let me know and I won't do it. But if you do like it, you can submit your own questions. It might be featured next time. They're all sort of picked randomly from one big bank right now. CSP Mosh, hello. Good to see you. Come on in, have a seat. T-Bay007, thank you for joining us as well. And I think it's everyone I've seen in chat so far. I know there's more of you out there lurking. Integer Man, there you are. That's Matt. And I'll do the monthly... sort of figuring out how to say his last name. Eland, I think. John Fulton, org. Greetings to you as well. Seth Petry-Johnson, check. It is on, in fact. I see you. Eland, yep, that's right. T-Bay with the Charizard. Little Pokemon there. All right, 601. 605. I'll start going through all these slides here. A little intro and give you sort of the lay of the land, and then I'll hand it over to Seth immediately after that. Swordfish Mint, L-A-Ed. Okay. Electric Havoc. What's going on? I like that emote there. Oh, it's Power Rangers Lightning Bolt. I like it. I just like lightning bolts in general, I think. The Azure Functions logo is like a little lightning bolt with angle brackets around it. My favorite logo. Elond? Elond. No, I think it's Eland. 23 people now. Yes, well, those counts, I'm not really sure how accurate these counts are. Like this one right here says 23, Okay, so I'm using some software called Streamlabs, which was lagging. It says 23 now too. So I don't know how accurate those counts are or how often they're updated. But yeah, 23. We've gotten up to I think 40 maybe previous meetings. So oh, you're on the Sacramento Placer user group in California. I mean, we just kind of fell into this the virtual thing. I wanted to keep it going. I can't meet in person right now. This is the third time we've ever had a virtual CONDG. Any plans for in-person meetings? So far, not yet. We haven't talked about it very much. I will mention this briefly, and we get to our slides. All of 2019, yeah, right. But there's, we'd like to get back in person as soon as possible, but the places that are hosting us, we have to talk about it with them, and certainly there's issues about serving food and things at meetups, which we took for granted in the past. So I don't know. We have to discuss those things. Things are starting to open up now in Ohio. This is where we're based. Some of you are not in Ohio, but you're certainly still welcome here. And it may be the case that we do some sort of hybrid, right? We may continue to stream onto Twitch or something and have an in-person meeting at the same time. We'll see. We'll see how it goes. Lots of stuff. Spud.ninja is their group in Sacramento. All right, cool. Who else? Someone else stopped by? Ginger Beard Man 4848. It's Joel. What's going on, Joel? We're glad you're here too. All right, about less than a minute here, and we'll get going. Oh, you've enrolled in Tech Elevator. Oh, your mind is a sponge. Are you here also because of Matt Eland? Integer Man. He's brought a few students here. I'm glad you could all participate. I'm really happy when I see students show up to the user group. That's a really good sign for me. You got your mod view ready to go. Okay, Calvin's got the band hammer ready. So watch it. Watch your comments, everybody. Okay, let's get going here. Kick off with the slide deck if I can find it here. All right. So make sure to follow us on social media, Facebook, Twitter. Sign up on meetup.com. All those sorts of things. CONDG.org. We'll get you to the meetup page. Next meeting, we may be having some kind of a hangout, like a Zoom or a Google Meet or something like that, where we can all kind of talk. It's not just me and the presenter talking, but all of us sort of interacting in advance of the presentation. And then, of course, we'd switch back to sort of classroom mode for the presentation. But we're discussing that right now. Sort of the logistics of that and how we're going to make that work. So keep an eye on the Twitter and the Meetup and Facebook for all that kinds of announcements and stuff and how that's going to work going forward. We are not able to be there in person at G2O offices, but they have always been so supportive of us in the past few years. So still want to give them a shout out. G2O used to be called ICC. It's their offices here in Columbus. I think they're moving offices, actually, so that's another part of the in-person factor. But thank you to G2O. We have some raffle prizes to give away today. We've got another JetBrains license, which will be the first place prize. And I've got a fresh infusion of Couchbase swag to give away as well. So the way you enter this is by just leaving a chat message in Twitch that will automatically enter you. The more messages do not equal more entries, so as long as you chat at least one time, you'll be entered into that drawing. Some shout outs to other user groups who I think many of them or most of them are still meeting virtually, but you're going to have to go and check their websites and their social media for details. So Central Ohio Azure Meetup, I think they use Teams recently. So you can go check them out at coazure.org. The Columbus App Dev User Group, they, I believe, have also met at least once virtually on Teams/Twitch. So you can go and check them out there as well. They do all kinds of mobile and, well, I mean, just a lot of stuff. It used to be very focused on mobile, but it's mobile, desktop, and all kinds of other stuff going on there. So you want to check them out for sure. If you are one of the few who are still working with SharePoint, for better or for worse, you can go check out the Buckeye SharePoint user group. I don't know I couldn't find anything about them meeting virtually or not. I assume they'll be meeting using some sort of SharePoint-based platform. I don't know. I'm just kidding. I don't know anything about SharePoint. But you can go check them out, buckeyespug.com. The PASS group, I couldn't find anything about them either, meeting virtually. But you can go check them out at columbus.sqlpass.org. I happen to know a lot of the PASS, the SQL Saturday events are being canceled, postponed, or made virtual. So you're going to have to go and check out, see what the Columbus group is doing specifically. Yeah, the safety check in the SharePoint group, probably a good idea. Let's Talk IT Columbus. This is a sort of a different kind of group. It's not focused around technology per se, but sort of the other things that go into technology that aren't about coding or specific pieces of tech. This is run by Aaron Petry, I believe, is one of the organizers. You can go check out their meetup group there. And if that Petry name sounds familiar, that's because there is a relation to our speaker tonight, Seth Petry-Johnson. So that's why he's shilling for it there in the chat. Upcoming conferences. So they're all virtual these days, right? So, but I do want to call out specifically the Live Coders Conference because it's here on Twitch, and I'm a member of the Live Coders team. This was a really cool conference last time, up to just a huge amount of people showed up for this conference. It got front page on Twitch and everything. It was great. So there's another one coming up on June 20th. You want to check that out for sure. Go to livecoders.dev to learn more information about that, or conf.livecoders.dev. Really good stuff there. That's coming up in June. Here is our meeting calendar as it stands to the best of my knowledge right now. So tonight is Seth Petry-Johnson about API endpoints. Next month, we've got a remote speaker all the way from Tulsa, Oklahoma. Is Sean Whitesell, and he will be talking about microservices. So that'll be interesting. That's one of the things that we've experimented with in the past, is having speakers from outside the area. And being virtual, it makes it a little bit easier to do. So if you have suggestions for people we should approach, we've got some things in the works, maybe getting Scott Hunter to come to a future meeting and present. July lightning talks, we're kind of discussing this right now. We're kind of leaning towards not having lightning talks. So I don't know. That's still in discussion right now. Just keep an eye on CONDG, Twitter and Facebook and stuff. And then Matt Eland is going to be talking about F# in August. So we've swapped him for Sean next month. He'll be out there in August. Okay, right now we're still making the assumption we're not going to meet in person next month. But if we do, we'll still have Sean present. It'll be virtually, like we did with Jeremy Miller last time. And we've got an updated title from Matt there. It's Modeling a Starship with F#. Still an introduction, but a lot more flair to that title. Usually when we're in person, one of the great things is you can actually meet with recruiters, and recruiters can meet with you and other people who are hiring. A little harder to do, but if you want to do that, if you're comfortable saying that you're looking for a position, you can do that in the Twitch chat. Feel free, absolutely, totally fine. And if you are hiring, also feel free to use the Twitch chat. However, if you are not eager to put that out in public, you don't want your current employer to know, for instance, you're welcome to email me. I will keep that confidential, and I'll be happy to make that connection to other people who are hiring and vice versa. So that's my email address there, my personal email address. Feel free to send me those emails. I've made a couple of connections already. I don't know how successful they've been, because I just sort of make the connection and then let them take it from there. But yes, feel free to use the chat or email me. It's up to you, whatever you want to do. Happy to help. You can be a part of the team. So we've got a team of great volunteers right now. These are pictures of all of them. And so if you want to help, you can, again, contact me via my email address, or just throw something in the Twitch chat there. I'm not exactly sure what we need help with, but we're always willing to bring you in to the fold and at least get your opinions or help or any sort of thing you want to do. There's an email address right there, condg.org@outlook.com. You can email all of us. I think I'm in on that. I'm not sure, but yes. All right. So if you've not used Twitch before, welcome. If you want to ask questions in Twitch chat, it's right there in the bottom right of your screen. Hopefully you can see this on your screen if you're on the desktop. If you're on mobile, it's going to look slightly different. You need a Twitch account to leave comments and ask questions there. I'm going to monitor this the best I can to ask questions and relay them to Seth as we go forward. I may be screening some of them and leaving them for the end of the presentation, but if they are relevant to the immediate topic, I will try to relay those to Seth. He may be monitoring the chat as well, but it's very hard to sort of monitor your slide and your notes and balance that with chat on the screen at the same time. So I'll do my best to try to deal with those. If you don't want to create a Twitch account, that's totally fine. You can still check out the video and watch that. I will also be monitoring the comments on meetup.com. So if you want to ask a question, you can go there to meetup.com, leave a comment there, ask your question. I will again monitor that and relay those to Seth as necessary. Okay, I think that's everything. So again, those are the channels. You want to watch those for future announcements. I'm going to take this stuff off the screen here, and I'm going to bring up Seth onto the screen here. And there he is. He is at a beach somehow. I don't know. What kind of magic is that? Can we get a quick sound check, Seth? Can you say hello?
Check.
Okay, looks like it's coming through. Can you all hear that okay on that side?
Man, this is weird. I have Twitch over here, and it's a major delay.
Yeah, someone told me it's like 20 seconds earlier, so I don't know if something's going on with Twitch. It's usually not that long of a delay. But
I can see my own ear if I look at
that is weird. Okay,
yeah, there it is. There's my ear. That's
amazing.
Ridiculous.
I'm going to take myself off the screen here because it looks like you're a giant peering down at me. It's kind of disconcerting, so let me take myself off.
That's the opposite of. That's how I feel whenever we're in person together.
That's how it is. Oh, the tables have turned. Okay, I think that's it. So Seth, take it away.
All right, so I need to share my screen. It's already sharing. Is it not? Hold on. Pardon me, maybe not. Okay. So many technologies going. So when that starts sharing, I'm then going to turn my video feed off because it's very disconcerting to have that. So I promise I'm still here. This is not like a robot, but I'm going to turn this thing off if I can figure out how. Come on. Good Lord. There we go. All right. So can I get a thumbs up in the chat? Make sure you all still hear me. Everything's good. Great. Okay, cool. So welcome to securing your API endpoints. This is one of my favorite talks to give. I'm excited to share it virtually for the first time. Over the next 45 to 50 minutes, I'm going to take you on a journey of discovery, at the conclusion of which you'll leave this virtual room a bit wiser and a bit more knowledgeable than you are right now. At least I hope so. Our journey begins with a confession. So a few years ago, I made a huge rookie mistake. I was writing a feature and I wanted a piece of JavaScript to make an API call back to my server. Unfortunately, it turns out that RESTful APIs are normally stateless. I couldn't rely on the server just kind of auto-magically knowing what user account was attached to the API call. I had to do something extra to tell the server what user was making the request. Now, if you've ever Googled how to authenticate an API, then you know it's a bit of a confusing mess. There's all kinds of things about bearer tokens and nonces and federated identity systems. There's people fighting over which is the correct cryptographic hash function to use to sign a request. Not one, but two different versions of this thing called OAuth that work very differently. There's this thing called a web token that some people says is God's greatest gift to the internet, and other people call a scourge on all mankind, right? So there was no guide to choosing the right thing for you. So I did a bad thing, went to Stack Overflow, a little copy pasta, rolled my own approach, got it wrong, and shipped a security issue. So My goal today is to give you the coherent overview that I desperately needed back then. I want to break down all the complex terminology and compare and contrast the techniques you can choose from when authenticating your own APIs. So the next time that you need to choose how to secure an API endpoint, I want you to start from a place of knowledge so that you can make an educated decision, and not a rookie mistake. So here's the basic structure of the talk. We're going to talk about 3 different concepts that you, as an API author, should be thinking about. We're going to use those concepts to compare and contrast the techniques that you can choose from. And then I'm going to wrap up with some suggestions on choosing a technology for your use case. I want to be clear about what this is not. So I am not a security expert, and this is not an advanced security session. If you already know the difference between OAuth 1 and 2, how to sign a request using HMAC, or how to use JSON Web Tokens to replace server-side sessions, you're probably not going to get a whole heck of a lot out of this. Because my audience, or my intended audience, is the people who don't know those things, or that those are the things they need to know to understand how all this stuff works. Also, this is not getting started with foo. Right? There are things I'm going to talk about that I have no direct hands-on experience with. I have never written any OAuth code myself, so I couldn't tell you what step 0 was, even if I wanted to. But what I have done is Googled the crap out of OAuth. Or more specifically, I've Googled the crap out of how OAuth compares to everything else you could do. And that's what this session is about. So I've packaged up all that research and I distilled it down into the most coherent format that I could create. So I want to strip away all that jargon and show you how these things work at a fundamental level. So I'm going to show you kind of how they work. You'll need to go elsewhere for the Hello World starter kit and whatever you decide you want to work with. So the subtitle here is a practical guide to API authentication, but we're actually going to talk about 3 different things: identity, authentication, and authorization. And they're related, but they're different. So identity is your app's concept of a user. So when the request comes in and says, yo, this is Alice, give me foo42, then Alice is the identity that's attached to that request. Authentication is the process through which we securely associate an identity with the request. It's how we know that it really is Alice making the request, or someone working on behalf of Alice. And then authorization is the process through which we validate the identity's permission to perform the request, right? It's how we know if Alice is actually allowed to access foo42. Now, just because a request is authenticated does not mean it's authorized, and a request can be authorized without being authenticated. And we're going to come back to that when we get to OAuth. So how do you authenticate and secure an API endpoint? Well, here's a list of everything that I'm going to explain today. Some of these things are standards based and they're built directly into the web servers. They require very little code to use, but you're also kind of limited in what they can do for you. Some of these things are custom implementations where you write more code, but you have more flexibility into what you do. There's different flavors of OAuth, and I'll talk about how they relate to OpenID Connect. And then at the very end, I'll have a brief honorary mention for some enterprisey things like SAML and WS security. Again, this is not a tutorial on how to integrate anything. I just want you to understand how these work and how they compare to each other. All right, so the first thing that we're going to talk about is client certificates. It's basically reverse TLS. So in TLS, there's a certificate on the server that proves the identity of that web server to the browser, right? That's how you get the little lock icons, so you know you're shopping, you're talking to Amazon and not someone who's hijacked the connection. Client certs do the same thing in reverse. You install a certificate on your browser, and it proves your identity to the server, and it allows the server to verify that the request hasn't been modified in transit. There's no login screens, there's no redirects. Every request is automatically authenticated, which is really awesome. But your users have to install that security certificate, and that doesn't scale, right? So this is not something that really works on the public internet. And this is really only easy to use if you're using something like Active Directory in IIS, because the tooling that connects a certificate to a user account is all built in. So these drawbacks mean that client certs are really best suited for internal APIs on a secure network. So if we can't deal with that, right, what's the next simplest thing that we could do? Next simplest is HTTP basic authentication. Internet standard, supported by every web server out there, and it's very easy to use. And the idea here is that the user credentials, the password and username, are concatenated together, base64 encoded, and then sent with each request as a header. Right? So every request comes through with this header in it. Server receives the request. It base64 decodes that string back into its original format, parses out the password and username, and then authenticates the request. Remember that base64 encoding is not encryption. So the server does not need any kind of special encryption key to do this, to convert it back to the credentials, but this header is being sent over the wire every request. So you must use TLS to secure the connection. If you don't, then any kind of man in the middle can take this header and easily decode it back to the password and username pair. Also, you're only as secure as the TLS implementation. So if that network protocol gets broken, like SSL did before it, these credentials are then essentially being transmitted in a breakable fashion. Now note that the authorization header here is poorly named. So this is all about authentication. It's about proving who the user is. What you do with the information once you've authenticated them is the authorization part. So the header is a little awkward there. So setting up basic auth is really easy, especially in Windows land. If you're on like .NET or something, you get authentication against a Windows domain for free with a simple line in web config. Now, for a public-facing website, you'd probably want to authenticate against a custom user database like your own profile system. And most platforms make it easy to do. The web server has some way that you to plug in some custom code. So it'll collect the credentials and you can kind of hook in to control the queries or whatever that goes to look up the user account. But even though basic auth is very easy to use, it has two main drawbacks. And the first is that it couples the API call to the primary account password. Because the way this is written, right, you're sending account credentials in that header. So if you have an API client hooked up using those credentials and you change your password, it's going to break that API client because that account credential will have changed. If you have multiple API clients all using that same credential, you can't revoke access from one without impacting all of them. And secondly, again, encoding is not encryption. So if you slip up and you don't use TLS on the request, then you potentially leaked that primary account password to anyone who's monitoring the connection. Now there's a way around that second drawback. It's called digest authentication. And the main difference is that with digest, the password is never sent over the wire. So there's less risk of it being compromised. Here's how digest works. So a client makes a secured reset or secure request, right? Give me foo40 or give me foo. The server responds the not authorized response and includes a nonce. And a nonce is just a number used once. It's just some random string that the server sends back in the response. The client then takes the username and the password that it knows, concatenates them with the nonce, and makes an MD5 hash of the result. The client then resubmits the request, passing the username, the nonce, and the hash all in clear text in a header. But the password is never sent over the wire. When the server receives that request, it takes the username from the plain text, it looks up the user's password, it then combines the username, the password, and the nonce, hashes them, and compares that with the client sent. And the only way they match is if the client and server use the same password to calculate that hash. And if the client and server agree on the password, we consider that proof of identity. right? The client has demonstrated that it owns that security key, that secret, so that means that we can trust that it is who it claims to be. So just like with basic auth, it's very easy to integrate with the standards, or it's standards based. And because the password's never sent over the wire, you can use digest without a secure connection. If someone is in the middle in that connection, the worst they would see is the username, because the nonce is garbage data, and the hash theoretically can't be easily reversed back into its original form. However, there are two main drawbacks to using digest. And the first is that MD5 has been broken, so those hashes really aren't secure after all. But there's one other issue as well. And that issue is that using digest prevents the use of strong password encryption in your database. That's because the server must be able to take a username and obtain the plain text password so that it can use that password to perform that hashing function. But the whole point of modern password security is to make that impossible. The use of any kind of one-way encryption method, like salting and hashing your password, will prevent you from using digest. And for that reason, no one really uses this anymore. It's important to understand, though, because this concept of using hash values to avoid sending sensitive data over the wire is going to come up again and again as we go down this list. Yeah.
A quick question, Seth, from the chat. It says TLS is not required, but would it be better to use TLS?
Sure. Yeah, so good question. So TLS basically does two things for you. It makes sure that anyone who's looking at the connection in the middle, like a man in the middle, can't see the body of the connection. That's always probably a good thing. It also makes sure that the request wasn't tampered with in process. So if someone is submitting form data or something, TLS guarantees you that no man in the middle tinkered with the form post and changed the account number or the amount or something else. So when I first wrote this, TLS was not as widely used as it is now. I think we're getting to the point where almost everything is encrypted by default, so it's less and less of a concern. Way back in the olden days, SSL added a not insignificant computational overhead to a request. But in these days of the 2020s, it's not a big deal. But yeah, if you can use it, there's no reason not to. Especially if you're using like digest auth, then you have kind of two layers of protection, because you have the TLS protecting the network, and if that is cracked, they still can't get to the credential because the hashing keeps that sensitive. So good question. All right. So these first three things work great if you want your API client to present actual user credentials during authentication, and if you're okay with the constraints that you get from kind of tying yourself so deeply into whatever platform you're using. But if those constraints are too limiting and you need more flexibility, either in terms of what information you use to authenticate with or how that information is transmitted over the wire, the next simplest thing you can do is implement a custom scheme using API keys or JSON Web Tokens. And we'll do API keys first. And the idea here is that it's generally more secure and more flexible to use something other than the primary account credential to authenticate the API call, right? You want some other way as that proof of identity to decouple it and separate it from that primary account credential. There's no standard of what an API key should look like, but in most cases they're GUIDs or some other kind of long, random, unique string. It's also important that these be assigned by you, not chosen by the client. By assigning the keys yourself, you can ensure they're unique, right? They're unique for that user. So if the API key does get compromised, there's no chance that that person's using the same key on a different website. And there's no chance then for the attacker to use that compromised key and attack a different service for the same user. There's two different ways that you can use API keys for authentication. The simplest approach is to treat the API key like a password and pass it over the wire with every request. This is basically the same thing as basic auth, but you're passing an API key, not an encoded username and password. This is called a bearer token because anyone that has that API key may use it to authenticate as a specific user, right? There's no additional security. They're like cash, right? So anyone that finds cash can spend it, no restriction. Anyone who has the bearer token can authenticate with it, no restriction. So you have to take care to keep it safe. So therefore, that usually means using TLS whenever you're using a bearer token to keep that thing safe over the wire. Now you can pass the API key in either the query string or an HTTP header. So the query string is really easy to do. It's great for kind of quick and dirty scripting scenarios, but you generally want to use the header. One reason that the header is more secure. So these keys are basically passwords, and URLs get put into log files that sometimes are not encrypted or are not always secured. And you really don't want a plain text password making it into your IIS log, for instance. And secondly, a header can't be leaked by copy pasting a URL out of Fiddler or the browser bar. So if I take a URL and I copy paste it and throw it up for my friend to look at, I don't really want them to see that link with my credentials in it, right? I'm meant to share the thing I'm looking at, not the ability to authenticate as me. So using API keys as bearer tokens is really easy, but there's one significant trade-off you have to think about. You can either have secure storage of API keys or the ability to show users a list of their keys, but you can't do both. Yep.
Got a quick question for you, Seth. This is just from me. You mentioned headers and you mentioned URL. Would a
Uh-huh.
would a cookie be an acceptable place to put one of these bearer tokens?
Sure, could be. Um, I don't really know why not. They don't show up in the logs, so that would be okay. Pardon me, I'm walking to grab refill my water while we're talking. Can't do this when I'm speaking in real time. Um, yeah, so cookie can work. Um, I think there might actually be some cases where when we get to web tokens, they might use cookies to pass it sometimes. So I'm going to go ahead and say no issue at all, with the caveat that I'm not a security expert and use my advice at your own risk. Sound good? All right. So you can have secure storage of the key or the ability to show users a list of their keys, but not both. And the reason is that API keys are basically account passwords. So you should consider salting and hashing them when you store them in a database. So if you store them as text and someone were to get access to your database, they then have access to everything they need to impersonate every user in your system. That's bad. But if you salt and hash the API keys when you store them, it will prevent you from showing a user a list of their actual API keys, right? Because that's the whole point. You want your system to be able to verify a token or an API key, but not to decrypt it to plain text. So you can sometimes have a user, maybe assign a name or a description to the key, but if you're hashing it for secure storage, you will not be able to show the actual API key back to the user. If you store them as text, then it makes it very easy for a user to see their list of keys, but you should probably implement some kind of expiration policy. At least that way, if your database is cracked, there's an upper bound on how long someone could use that data to impersonate people. Depends a little bit on your threat model. So the other way to use an API key is to use it as a cryptographic key to sign the HTTP request. This is basically a custom version of digest authentication, but we're using an API key to sign the request, not a password. This way, the actual password can be properly secured and hashed and salted, and the API key can be used to sign the request and be fully decoupled. And here's how signing works with API keys. So the client prepares the message, which is either the URL, the form post, or whatever. The client then concatenates the API key to the request they want to send, and they run that whole value through a hashing function. and that generates a signature. The client then sends the original message to the server, right? The URL, the form post, whatever, and it sends that signature in a header or a cookie if you're Mac Groves. The server takes the request, it looks up the API key for that user, repeats the hashing operation, and again, if they match, the server knows the client used the same API key. So server, client agree in the secret. That's proof of identity. Now, the authorization header is a type of message authentication code, or a MAC. And because this case we're using a hashing function, this is called a hash-based message authentication code, or HMAC. And HMAC has a lot of benefits, right? Like with Digest, the credentials are not being sent over the wire. There's less risk of them being stolen. So again, does not require TLS, although if the message itself is sensitive, you still want TLS to secure it, but you don't need it to keep the credential safe. Secondly, unlike with bearer tokens, the server can guarantee that the message it received was not modified in transit. Because if anything about that request is changed, if the URL parameters or the form parameters are modified by a man in the middle, then the server is going to calculate a different hash result. They're not going to match, and the server will know that it's not a valid connection. The primary drawback to HMAC is complexity. So the client and the server must compute the hash exactly the same way, right? If they do anything different, then those two, they're not going to get the same result. And this usually requires publishing very detailed instructions that describe like how to canonicalize the request data prior to hashing it. So I took a screenshot of the instructions for signing an AWS API call, and it was just pages upon pages of stuff. There's 4 screenfuls here that I've pasted here. This is only a portion of it, right? These are all the instructions that you have to do to get your request ready in order to hash it to do the AWS API call. And the complexity is a necessary part of using HMAC. It's the price that you pay for the increased security that you get from the signed requests. Now, in order for signing to work, the request must include at least 2 things. It has to have the signature that was created with the API key. That's the result of the hash function. It's right here. And we also need a pointer to the identity that owned the API key that was used in that hash. And the identity is needed so that the server knows what API key it needs to look up in order to recompute the signature. So that means that if you build an HMAC system, you'll have to choose what to use as the identifier and what to use as the secret value when signing the request. Now, you could use the user's ID or email address as the identifier. That makes it harder to support multiple API keys for a single user, because the server needs a way to determine the specific API key used to sign the request. If you pass the user ID as identifier, and that user has multiple API keys, the server will have to kind of loop through all of them looking for a match. So a better approach is to issue API keys as a key pair. One public key that's sent over the wire in plain text as identifier, and a private key that's used in hashing. That way you can have multiple keys per user, but the server can still do a direct primary key lookup to get the private key associated with whatever you pass as the public identifier. Remember that to do request signing, API keys must be stored in plain text or with reversible encryption, because the application has to get access to that plain text value in order for this all to work. And again, storing it in text means it can be compromised if an attacker gets access to the database. So again, consider an expiration policy for your API keys if you go this route. So the last detail of an API key implementation to think about is, how does the client come to know the key in the first place? Doesn't matter if you're using bearer tokens or HMAC, the client has to know that secret value, right? That knowledge is the key to authentication. And if you're writing a server-based client, it's pretty easy. The programmer obtains the secret value from some secure mechanism, right? They go and they find out what that key is supposed to be. The programmer then puts that key into the source code or a config file or something, and then the client can use that key when it makes API calls. And assuming that you're properly securing the client and you don't let people just read the web config over the public internet, then the key itself is kept secure, and that's fine. But it's more complicated for a JavaScript client because there's no way to preload a key up front. Users can log in from any browser, anywhere in the world. So how do you get that key onto the client? Well, you could require the user to authenticate first by logging in, right? If they log in, so you validate their primary account credential, you could then send an API key back to the client in the response to that login request. But the problem is that the client cannot securely store the key because JavaScript is not a secure environment. The crypto functions can be monkey patched, local storage can be attacked with cross-site scripting. So basically, anything you expose to JavaScript is open for inspection. And if the API key is sensitive, right, how do we give it to JavaScript so that we can use it for making API calls without letting an attacker see that private value? And the answer, or one answer, is JSON Web Tokens, pronounced JOT. JSON Web Tokens are an open industry standard method for securely representing claims between two parties. And claims are nothing more than pieces of data, right? It can be demographic data, like someone's name. It could be a user preference, like the fact that I don't like XML, or it could be statements about what a user can do, like the fact that I'm an admin in whatever system this is. And since this standard is called JSON Web Tokens, right, surprise, surprise, they're expressed using JSON. So once these claims are generated, the server will cryptographically sign the claims, like we saw with HMAC. It creates a token. It gives that token to the browser, and the browser resends the token back to the server with each request. The server can then validate the token and use the claims as it needs to, like for authorization. So let's go through that again in a little more detail. So using JOT, the user still needs to securely authenticate themselves by logging in, right? We still need some way to know, to securely identify the user behind that JS client. So we require someone to log in through a form post or login screen. Once the server validates the credentials, it creates a JSON document indicating the user has authenticated and then specifying their permissions or their demographics or whatever else that we want. And those claims are encoded as JSON. Then, using a secret key known only to the server, the claims are hashed in creating a signature. Finally, a token is created that contains the claims in plain text and a signature. The signature is then sent back to the client. And from there, the client resubmits the token with every subsequent request. I'm going to pause for a second because my Twitch stream just hung up. Am I still live, Matt? We still good? Okay. I lost it over there, and that's fine. So the client resubmits the token with every request, and the server extracts the claims and then recomputes the signature. So if it calculates the same value that was in the token, the server knows the claims are valid because they only could have been signed by someone in possession of that private key, right? If the claims had been modified in transit, then the hash functions wouldn't match. Again, this is very similar to signing API keys, but in this case, only the server knows the secret key. The client's job is just to store and resubmit the token. And if the token passes validation, the server knows it can trust the claims. So JOT tokens consist of 3 pieces of data separated by a period. The first is a standard header that typically indicates the type of token and the hashing algorithm being used. So in this example, we're using HMAC SHA-256. Now, in fact, the ability for the client to choose which hashing algorithm is used is a core piece of the JSON Web Token standard. It's also one of the reasons that some security experts don't like JOT. Though discussing why is outside the scope of this talk, just be aware that not all security professionals favor for JOT. The second piece of data is the payload that contains the actual claims that we're making. So the JOT spec defines a handful of predefined claims called registered claims. These are optional, but if you want your token to be easily used between systems, using those claims is like a schema of some well-known names that you can use. So in my example here, I'm using the subject claim to represent the ID of the user that's logged in. So that just allows for some interoperability between systems. But you can also create private claims to hold whatever data you want. In my example, name and the isAdmin flag are private claims. So the third piece of data is the signature, which is calculated by combining the header and the payload together and then hashing them through the hash function. Finally, the base64 encoded header, the base64 encoded payload, and the signature are all concatenated together with periods, and you get the final token like you see at the bottom of the screen. That string is what gets sent back to the browser, is then echoed back to the server on the subsequent requests, usually in a header. Now, the really cool thing about this is that claims make JOT tokens self-contained and stateless. So you don't need to just say, the user ID is 12 and then rely on the server to go figure out what user 12 can do. The token itself can state the actual permissions. It can say, this is user 12 and user 12 is an admin. And because the server validates the signature, it can trust that. So that can really help with performance, especially on a very chatty API, because you don't need to have the server repeat your access check on every single request, right? It can skip database lookups and use the permissions stated in the claims as a way of streamlining some of your authentication. Now, it's important to note that even though the token looks like gibberish, the header and payload are encoded, not encrypted, and anyone that gets access to that token will be able to read the claims. And this brings up some interesting trade-offs regarding where you store the token on the browser and what sort of access code or access your JavaScript code has to it. So once the server sends your JS client a token, you can either store it in local storage or in a cookie. The advantage of local storage is that your JS code can access the claims. So if you're writing like a single page application and there's data in the claims that your app needs, then that's great. The JS code can get the data out of the claim itself. The downside is that the information stored in local storage can be attacked with cross-site scripting. So you should only do that if the data it contains is not sensitive, right? So the fact that I don't like XML, not a big deal. But you probably wouldn't want to put my social security number in a claim and then put it in local storage. So the other option is to put the token in an HTTP only secure cookie. There's your answer, Matt. This way, the token is protected in transit by TLS, also protected against cross-site scripting. However, that HTTP only cookie makes it not visible to JavaScript. So in this case, the claims themselves can only be used by the server for server-side authentication and authorization, but the JS code itself would not be able to extract data out of the token itself. So API keys in JSON Web Tokens are far more flexible than client certs, basic auth, or digest auth, and they're relatively simple to implement. And they work really well for server-to-server authentication, but they're less useful when authenticating real people because real people don't want to type in GUIDs or type in hashes. So if you really want to authenticate people and you want to use more than a password and a username that you control, the next step up would be OAuth. Yes. Okay.
Question just came in, Seth, and if you want to save this till the end, that's fine too. But what are your thoughts on using JWT? You keep saying JOT, by the way. Is that the correct
Yes.
pronunciation? Okay.
JOT is the
Okay, got
pronunciation.
it. What are your thoughts on using JOT with one of the claims being the IP address used to log in originally? Then each feature call could compare the current IP address against the JOT claim's IP address.
Is a way of kind of like securing or checking for it being compromised. Yeah. So I
I
think
guess so,
the
yes.
the um, the interesting thing about web tokens is you have to start thinking about the fact that it's stateless. So you, for instance, you might say, well, this says that I'm going to deviate the question a little bit, but I'll get back to the IP address. The token might say that user 12 is an admin, but people's permissions can change. What happens if someone demotes user 12 to a normal user, but their token still says admin? Will they still be able to act as an admin? The answer would be yes. So you probably want to do things like periodically revalidate. So check the IP address, put an expiry on it. So you say, well, I'm going to trust this token for 5 minutes. After 5 minutes, we're going to go ahead and re-hit the database again and revalidate stuff just so we have a limit on how long a compromised token could be used for. I think as far as I know, there's no standard for doing that. It just kind of comes down to your logic and how you want to build it. It's kind of the trade-off between the flexibility of having a token tell you what's going on, and then your desire to validate that. So we've never done anything with the IP address, but we have done things with expiry type things where we only trust it for a small amount of time. So I want, like, if I'm doing a very chatty API and there's 10 calls in rapid succession, I don't want to check security rights on each of those 10 calls. But 5 minutes later, I'll probably want to validate again. So did I answer that question appropriately? Cool. All right, so on to OAuth. OAuth is a way to authorize devices, APIs, servers, and apps using access tokens, not credentials. And it was originally designed to solve the problem of delegated authorization in a three-party scenario. And it does that by building on many of the things that we already talked about. So to explain what I mean by delegated authorization in a three-party scenario, first let's look at a traditional two-party scenario. So in a two-party scenario, the client uses its credentials to access its data on the server. So OAuth calls this a two-legged model because there are two entities involved. An example of this would be server-server communication, where the client server is just directly authenticated to the server, and here's my key, give me my data. In other cases, though, the client is acting on behalf of a different entity. Now, in those cases, the client is not accessing its own resources, but those of the final end user. And one way to do that is for the end user to share their credentials with the client so the client can then use them to make an authenticated request. And that's fine if I trust the client, right? If I don't mind the client technically impersonating me when it talks to the server. But what if I don't trust the client with my credentials? So let's say I have some photos that I've put on Facebook, and I want to use the Acme photo printing website to create greeting cards with the photos. I really don't want to give Acme my Facebook password, but how else is it going to get access to my photos? And that's the exact scenario that OAuth was designed for. It's called a three-legged model because there are three parties involved. It's the resource owner that owns the content, that's me. It's the service provider that hosts the content, that's Facebook. And there's the client that accesses the content, that'd be Acme. OAuth allows me to authorize Acme to read my photos, but without sharing my actual credentials. And when I do this, Acme is not making an authenticated request. It's making an authorized request. And we'll talk more about that here in a second. So here's how it works kind of technically. Right? The user starts out on the client's website, Acme Photo. Acme redirects the user, me, to the provider, Facebook. I would authenticate to Facebook so they know who I am. And Facebook would then display this page that we've all seen to collect an authorization to share my data. Right? In this case, the screenshot is Spotify, but Facebook, whatever, it's all the same thing. So I say, yes, I want to log into this service with my Facebook credentials. So you authorize it, and then the flow continues. So you are then redirected back to that client website along with an authorization grant. The client makes some back-end calls, and they trade that auth grant for an access token, and they use the access token to call APIs. So the details there can get wonky, but at a high level, that's how OAuth works, right? You get an access token that lets you make an authorized request without authenticating. Now there are two versions of OAuth, and they implement this flow very differently. And it's not universally accepted that the newer version is best, although I think it's probably getting the most use. But we'll talk in a minute about how they're different. So OAuth 1 uses signed requests. So like you remember from HMAC, does not require TLS, and the message integrity is guaranteed. So you know it was not modified in transit. OAuth 1 works best with web-based clients because the user must be sent to a website to do the authentication and the authorization. And the primary drawback of OAuth 1 is just all the complexity from the request signing. Libraries can mitigate it, but it's still a lot of work. OAuth 2 was designed to be simpler and to better support non-web clients. It's an entirely different implementation. It is not backwards compatible with 1. In technical terms, OAuth 2 uses bearer tokens instead of request signing. And that makes it much easier to implement, but you have to use TLS to keep that credential safe over the wire, and you lose the ability to guarantee that a message wasn't modified in transit. Although if you're using TLS, you get that network level stuff from TLS itself. OAuth 2 also supports more flows than 1. So it supports some enterprise use cases. There's some ways to do that access grant that don't require a web-based redirect. Now it's important to note the 2.0 spec is considered a framework, not a protocol. In order to support that wider range of authorization workflows, many decisions are left up to the implementers. This can hurt interoperability. So if you have two providers that say they're OAuth 2 compliant, the code that you write to work with one provider may be entirely different than the code to work with the other one. Right? You can't take one library for login as Google and turn around and use it for Yahoo because they may have very, very different implementations. And there's some controversy around 2.0 as well. So the guy named Aaron Hammer was the lead author for the OAuth working group, but he withdrew his name from the 2.0 spec prior to publishing it. And he wrote this blog post called OAuth 2 and the Road to Hell. And he writes, when compared with OAuth 1, the 2.0 spec is more complex, less interoperable, less useful, more incomplete, and most importantly, less secure. He goes on to say, if you consider yourself a security expert, use 2.0 after careful examination of its features. If you are not an expert, copy the implementation of a provider you trust to get it right, or make sure you have experts on site to figure it out for you. So that might just be sour grapes, right? Maybe he has a different vision for OAuth. But if you're going to pin all your hopes and security dreams on OAuth 2, make sure you understand the security trade-off before doing it. Let's talk about authentication versus authorization again. OAuth is a standard for delegating authorization to an API. It's about you, as a resource owner, authorizing one app to access your data from another app. It is not an authentication protocol, and it should not be used as one for two reasons. First, the whole point of authentication is to securely associate a request to an identity. But OAuth access tokens don't tell the client anything about identity because, by definition, access tokens are opaque to the client. The client gets a token from the auth provider and it uses the token to make an API call. The token itself is a black box, right? The client cannot parse it, cannot extract data. It's completely opaque. Therefore, the access token can only tell us that the request is allowed. The token alone can't tell us who is making the request, and there is no authentication without a who. But what if the access token authorizes you to call an API that will return user information about identity in response, right? So let's say that you call the authorization server and you get a token, and then that token lets you call an API, which returns the email address associated with the related identity. Is that sufficient for authentication? And the answer is no, because there's no guarantee that only that one user was able to authorize the access, right? If more than one entity could have given permission for you to call this API and get my email, then you cannot use possession of that authorization as proof that it's actually me on the other end. This might be easier to understand with an example. Let's say we have a website called badguy.com, and it lets people log in with Facebook. So I go to badguy.com, and using the normal OAuth flow, I authenticate against Facebook, and then I authorize Facebook to give my profile data to badguy.com, right? So badguy takes the token, it calls Facebook's API, gets my email address, and now considers me authenticated and logged in as me. Now, at this point, bad guy has access to the email address of my Facebook account, which I granted, and I have full access to my account at bad guy. So far, so good. But shocker, it turns out that badguy.com isn't trustworthy. It turns around and it tries to log in as me to victim.com, which also allows a Facebook login. But this time, when victim does the Facebook redirect to do the OAuth flow, bad guy ignores it. It just resubmits the access token they obtained earlier when I logged in. So now, bad guy has given to victim the same access token that they got originally. So victim then turns around and calls the API, uses that token, and gets my email address back. If victim uses that as proof of authentication, it will have allowed bad guy to access my account at victim. Now, neither of those two sites have any more access to my Facebook account than my email address. That's not a problem. The problem is that victim has allowed bad guy to authenticate as me. This is possible because OAuth access tokens do not have audience restriction built in. It's a problem with bearer tokens in general, right? Victim has no way to know that it's being compromised. Now, to avoid that problem, only use access tokens to access the authorized resource. If you use possession of an access token as proof of authentication, then you're vulnerable. And to solve this problem, the access token would need to be not as opaque. It would need to assert what client it had been granted to and which identity had done the authentication in the first place. If the token had that information, then only bad guy would be able to use the token they got when I authorized it. And that token could also serve as proof of identity to the authorized client. And that's the basic concept behind OpenID Connect. So OpenID Connect is an open standard that defines an interoperable identity layer on top of OAuth 2.0. And it allows authentication against a third-party identity system by closing those gaps we just mentioned. It adds extra tokens that are given to the client in addition to the normal OAuth token. These have a well-known format, so the client can parse them out of the token, and they provide things like audience restriction, they provide the identity claims, and so forth. So OpenID Connect replaces OpenID 2.0 and is the best technology for authenticating against a third-party identity system with your app or API. So AWS Cognito is a new addition to this talk. Cognito is a managed OpenID Connect implementation that runs in Amazon Web Services. So you can use it to authenticate against AWS accounts, as well as against third-party providers like Facebook, Google, etc. And the cool thing is that Cognito even offers a managed hosted login UI. So you don't have to code the login form itself. You can have the entire process of logging in, choosing your provider, going over, doing the OAuth flow, and then coming back with an access token. That whole process can be managed and delivered through AWS with very little code on your site. So we recently used this on a project at work, and it was stupid simple for one of my developers to set it up. He told me that integrating it with .NET Core 3.1 was a breeze. So if OpenID Connect sounds good to you and you're using AWS, then give Cognito a look. It's pretty sweet. Yeah.
Seth, I want to back you up just real quick here. Back to the OAuth 2 example of the bad guy and victim.
Yep.
A question came in. That scenario you described, is that something that can also happen in JOT as well?
Well, it depends, right? So the thing with JOT is that the server knows that it signed the key. So if I take a token, how do we think it through? So if victim, I log on to bad guy, and there's a token on my machine, and then I go over to another site. The other site, it would be a problem if the other site didn't validate the token, right? So if I say, here's my JOT token, and it says, oh, I see you're Seth, great, then there'd be a problem. But if it does that hashing where it recomputes the thing, and it has the right security key, then it knows it signed that key originally. So I think it's a little bit of a different scenario. It would depend on how you use the claims in the token. So if you're using it as proof of identity, then yes, I suppose it could happen, but it's I don't know, it's a different scenario. Let's come back to that one when I get to the end, because I kind of want to noodle through it and think about the details.
Okay.
I think the fact that in this case we have the server is sort of issuing its own claims and then validating them is the difference between using access to the identity API as proof of authentication.
Okay. Sounds good. Ken, I have another question that came in back to AWS Cognito. Some
Sure.
comments and questions coming in. How would you compare Cognito to services like Auth0 or Okta?
Or
Is it the
Okta.
same sort of thing, or is it a
That's a
different
great
offering?
question. I don't know for sure. I think it is. I mean, as far as I understand, like Auth0 and Okta they're building things on top of OAuth. I don't believe anyone out there is implementing an alternative to OAuth. Although I think one of those might be very JOT centric. I did some research into those companies a while ago. It's been a while. So yeah, there's a lot of places that are doing kind of this like identity as a service. And I would say it's probably similar. I don't know for sure. I know that Cognito is essentially managed OpenID Connect in AWS, and there may be other ways to manage it using non-AWS. All right, good questions. Let me see, where was I? Okay, so quick summary then. So OAuth 2 is a broad spec for authorization. OpenID Connect is a detailed spec for identity on top of OAuth 2. And Cognito is a managed OpenID Connect implementation in AWS. So these things kind of stack on each other. I would not be surprised to see that Auth0 or Okta are similar to Cognito in that they're layering things on top of OAuth 2. All right, so to wrap up, I'll touch very briefly on two final things. The first is SAML, which stands for Security Assertion Markup Language. It's basically the same thing as JSON Web Tokens, but it uses SOAP and XML, not JSON over HTTP. So SAML is older, it's more complex than JSON Web Tokens. It does have additional functionality that is sometimes used in enterprise single sign-on scenarios, although JOT tokens are being used, I think, more frequently to do single sign-on, at least lightweight single sign-on. But SAML is still very present in the enterprise. And then the second is WS security. And honestly, I don't know much about it. If you're dealing with complex enterprise grade authentication scenarios, then you want to hire a professional. I would not use my little 101 level intro to do anything with WS security. All right, so I just threw a metric crap ton of information at you. We talked about a lot of different choices and a lot of different trade-offs. And so the answer to the question, what should you use, is, of course, it depends. So client certs are pretty easy to use if you can get users to install them, right? They're not a good fit for the public internet, but they might be a good fit if you're doing like a private API against Active Directory or in an enterprise somewhere. Basic auth could be a good fit for server-to-server API calls against a standard user database like Active Directory. Just remember that you're passing the primary account credential over the wire in plain text. So this probably isn't something you want to do unless you're just looking for a really quick win with very little code. Using API keys as bearer tokens, where you pass the key itself with each request, is really easy to implement. So it's great for rapidly standing up a new API when you don't need top-notch security. Just remember to use TLS for all requests. If you want more security than you get with bearer tokens, then use API keys to sign the request. Now, in this case, doing that signing can be complex. The server and client must create that hash in exactly the same way. So if you own the server and the client, this is not a big deal. But if you're going to be supporting third-party clients, then be prepared to document in great detail the process for doing that signing process. JSON Web Tokens are worth a look if you're writing in JS client. They can also be used for lightweight single sign-on or tracking something like a session state or state without a server session. Remember that this does require a secure login with user-entered credentials to initialize the token up front. So JOT is not a good fit for automated server-to-server interaction. Or I guess more accurately, JOT is a fine way to handle authorization in a server-to-server model, but it relies on something else to establish the authentication, right? As long as you have some way to know the identity is correct, then you could use JOT for server-to-server just fine. OAuth is a good fit if you want to support delegated access to user data. So consider the 1.0 version if you only need to support web-based clients and you want maximum security. Just remember that it's the primary drawback is all the complexity from the HMAC signing. So the libraries can help, but it still is a bit more work. If you need to support a wider set of devices and auth flows, or if you care more about flexibility and simplicity than security, then OAuth 2 is a better fit than 1. Just remember that it's a framework, not a protocol. So there may be very big differences between provider implementations. And of course, OAuth is for authorization only. If you want to authenticate against third-party data, then use OpenID Connect on top of OAuth 2, and you can build it yourself or use something like AWS Cognito that make it really simple with a more of a hosted solution. And lastly, you should use SAML or WS Security if you have a sick love affair with XML or you have literally no other choice. And if you're creating your own API for your internal use, these things are overkill. They're probably not worth it. So I will pause here for a quick second. I know in-person talks, people always want to grab like a pic of the last slide. So now for your screenshotting pleasure. And that's it. So my slide deck and the speaker notes are all on GitHub, which you can get to right there. And if you have questions, comments, stock advice, whatever, you can hit me up on Twitter or via email, or I can hang out here on Twitch for a little bit and answer questions. But thank you all for your time. I hope you enjoyed it.
Thank you very much, Seth. We do have a few questions and
Absolutely.
some prizes to get to, but at this point, it's also the time when there's thunderous applause for such an excellent presentation. We really can't experience that right now, but on behalf of people who can't hear their clapping, I applaud you. Very good job. Thank you for being with us. I appreciate it. A couple quick questions. This is from way back at the beginning. I wanted to save it towards the end because it seemed like a topic that was a little broader. Maybe you just have a quick bit you want to mention about this. But the question was, can we talk a bit about TLS versus HTTPS?
Sure, I can. So if the person asking this is a protocol geek trying to trip me up, then you're going to win. So HTTPS is secure. So there are different layers, I think, of the TCP/IP stack, the way I understand it. So TLS or SSL is the network level, TCP level encryption that happens at the network layer. HTTPS is the HTTP protocol being secured on top of the secure network layer. So I think I got that mostly correct enough. But if you want to go out and Google it and tell me how wrong I am, you will probably be able to do that pretty easily.
It seems like that satisfies the person asking the question. Just monitoring the chat here. One more question, and this one is about resources you could recommend to implement TLS. It seems extremely important when using bearer tokens with both API keys and OAuth.
As far as I know, you basically get it for free with most of your web servers. I mean, like you can go in and configure IIS to say, right, you don't use SSL, use TLS. I mean, it's something that you as an application developer should not have to do. Whoever runs the web server should be able to say, we have implemented TLS, and when someone goes to https, us.com, they're going to be on a secure connection. So the main thing is to make sure that you're using HTTPS. If you're doing that and the browser is not yelling at you about connection problems, then you are on a secure connection. If you're trying to do just plain HTTP, then there is no network level security going on.
Okay. I think that's all the questions I have. If there's any more, feel free to put them in the chat there. Seth, could I get you to stick around for a few more minutes while we wrap up? Is that going to be okay?
Yeah.
And
I'm just going to grab a frosty beverage.
If you don't mind, I'd like to put you on the screen one more time in lieu of applause.
Well, let me come back.
If you don't mind.
Let me get my beverage. And come
okay,
back.
That's fine.
Because now there's no one. You'll see an empty chair.
We were talking about your legendary G&Ts while you were presenting, by the way.
Yeah, I decided to forego a beverage until afterwards.
Well, I think it's much deserved. All right, so I do have some prizes to give away. Oh, people want to see your chair, Seth. They want to see the chair. They demand it. We do have some prizes to give away. I got a fresh infusion of swag from Couchbase, so I'm going to show you best I can here on the screen. Oh, yes, thank you, Lambert Pix, and feel free to share any other openings you have in the chat. And again, you can email me at mgroves.com if you have anything else you want. If you want to be more discreet, happy to make that connection. I'm going to make a note of that, by the way, Lambert, in case I get an email from someone. Thank you for sharing. There's Seth on the big screen. Say hi, Seth. I'm going to move you over here, get a little bigger shot of you. Okay. So what we've got here is I've got the same raffle as we did last time. Basically, just put a message in the chat at least once, and you'll be entered to win. More chats do not get you more entries. So just I'm going to do a select distinct. I'm going to go run down the prizes here, starting with third place. So third place is this fine Couchbase branded Moleskine style notebook with lots of blank pages and a pen that comes with it as well. I think can also act as a stylus. So very nice little prize there. That is third place. Second place is just like I gave away last time, this little AT robot. He's voice controlled. He can record things. He dances around, all kinds of fun stuff. Little smart robot type of thing there. So that is second place. Both of those prizes will also get a little Couchbase pin and sticker pack. More stickers than what are shown here, but that's kind of the idea. You're going to get those as just kind of a throw-in. I got a whole bunch of those to give away. Calvin, if you want a pin, I'll get you a pin somehow. That's the privilege you get for being a organizer. And of course, the first place prize, which I don't really have to show you because it's just an email, a PDF file basically. It is a license for a JetBrains product. Maybe I can bring up just the JetBrains website on the screen here in lieu of any sort of physical object. But here you go. JetBrains, makers of fine products like a ReSharper for a Visual Studio plugin and a writer, of course. You don't have to necessarily get those. There's other products there as well. IntelliJ stuff, Data Grid, all kinds of great things you can get with a JetBrains license. Oh, you must be present to win this prize, which means you must be here, so you can give me your contact information. You can just an email address is good enough. If you're outside the United States, I'm sorry, I can't ship these things to you. But the JetBrains one I think will probably be okay if you're outside the United States. Not 100% sure on that. But I will bring up now, unless there's any more questions for Seth, I'm going to bring up the little my little SQL query to select a prize winner. All right. Okay, so this is a database of all the chat messages that go into Twitch. My chatbot sort of scoops them up and stores them. And then I've got a timestamp, so I'm selecting distinct users, ordering them by random and picking the first one. And so this is for the third place prize. It is just, again, to remind you, it is the notebook here with the fancy stylus pen. Does it filter moderated messages? I don't know. That's a good question. Okay, here we go. The first winner is Gingerbeard Man 4848. Are you still here, Gingerbeard Man 4848? Just say hello in the chat. And I'm going to copy that message from John Fulton as well. Yes, you are here, Gingerbread Man. Gingerbeard Man 4848. So if you could send me a private message with your email address, you will win. I will ship this to you with stickers and pins. It will arrive in the mail. I will ship it at my own expense. Not really. I think I'll make Couchbase pay for the shipping. So I will send that to you. So congratulations, Gingerbeard Man. Next up is the robot. So this is the second place prize. I will hit the execute button here again. And let's see who wins. It is Azunex. Azunex. Are you around, Azunex? Please say something in the chat, or we will give your prize to the next person. Azunex, are you there? Zoom in a little bit. Azunaix. Yes, Azunex, you're there. Please send me a private message with your email address so that I can get your mailing address, and I will ship this robot and a Couchbase pin and sticker pack to you. Congratulations. All right, 2 down. Last prize is the JetBrains license. I will, again, need you to be present to win because I need your email address to send you this license. Okay, drum roll please. And the winner is TBay007. TBay007, are you there? Are you still around? If you're still around, TBay007, you will win a JetBrains license. There he is, TBay007. Congratulations. Please send me a private message with your email address, and I will get this certificate over to you. Thank you very much, everybody. Congratulations. Is there anything else I need to say before we wrap up here? Make sure to follow us on Twitter, Facebook, and Meetup, all that stuff. We're going to do maybe something a little bit different in person, like sort of a group meeting, like a Zoom or a Hangout or something like that. If it's okay with Seth, I will post the video to YouTube of this presentation so you can watch it again. I'll link to all those resources that Seth says yes. I didn't want to put him on the spot, sorry. But I'll link to those resources as well. Those will all be posted on Meetup and Twitter and whatnot, so always check those things out. Thank you, everybody, for hanging out with us and making this a really great, this is probably our best one yet in terms of attendance and participations and chat questions. I love it. And I think it's mostly due to Seth's great presentation. So thank you again to Seth. Another round of applause. That's pretty much it. I'm going to let you all get back to it. You don't have to go home, but you can't stay here. I'll turn on one more round of trivia just to play us out. But thank you, everybody, for stopping by. And I hope to see you again next time. All right. Later on.